Hello, welcome to Block 2, Use of Algebra Notation, Lesson 8. I'll share my screen. So, in your previous lesson, you learned about two-step function machines using only numbers. So, you worked using inputs to find the outputs of two-step function machines, and you made progress to find out the inputs of those two-step function machines when you were given the output by using inverse operations. In this lesson, we will focus on understanding the fundamental concepts of algebra using two-step function machines, but this time our inputs will be letters and diagrams. But before we start, I would like you to recall most of what you learned in your previous lesson by doing the retrieval practice. You can pause the video and do the retrieval practice in 3 minutes. I'm going to assume you have paused the video, you've really thought about what what the solution is to these retrieval practice questions, because they help you recall what you learned in your previous lesson. So here are the answers. Let's discuss them. Okay, here for question 1, you were asked write down the expression represented by the bar model. Okay, so we have, remember, for the bar model, we always add the bars. Okay, so if we're adding 6 bars, of which each of the bars is t, then we actually have 6 lots of t. So we can write this, if you remember from our previous lesson, we can write this as 6 times t, or t times 5. Okay, 6 lots of t, or t times 6. Sorry, t times 6, which is 6t. Here, question 2, you were asked, write down the expression represented by the bar model. Again, for the bar model, remember we add the bars. So this is 4 lots of t plus 2. Okay? 4 lots of t plus 2. So we write that as 4t plus 2. Here they're asking you what's the same and what's different about the bar models in question 1 and 2. Well, both of them have 6 parts, but in question 1, all of the parts are equal. Whereas here, all of the parts are not equal. We do not know the values of t. Okay, we do not know the actual values of t. So we have 4t plus 2. Okay, let's move on. If I give you this function machine, and then my input is a diagram, which is a block, okay, I do not actually know the value of this block, but all I am interested in, according to the function machine, we just need to make the blocks. We're not just 3 times bigger, or 3 lots of the blocks. So what we have is this. But if I then say, well, there is remember we're doing two-step function machine, there is another part of the function machine which means which is to add 4. Well, we do not actually know the value of the blocks, so we have to find another clever way of adding 4. So what if we say, let's use small green blocks to represent 1. So it means if we're adding 4, we're going to be adding 4 green blocks. That means our result will be 3 blocks plus 4 green blocks. Okay? But if we write it the way we normally combine the function machines, we're going to have 1 block plus another block. Okay? The function machine block, I mean, times 3 plus 4. And then this will be our output. Now, what if we reverse the operation? Do you think we will have the same result like we had when we used numbers? Remember, when we use numbers, we learned that reversing or changing the operations, the order of operations of the function machines will affect our result. Will it be the same? Let's check. So if we're adding 4, it means we actually have a block. We don't know the value, so we can't just add 4 to it. So we need to say, okay, let's add 4 little green blocks, okay, to represent the actual numbers. So 1 green block represents 1. So we have 4 green blocks. So this is what we'll get. Now, if we are making these 3 lots, if we're making 3 lots of this, then it means we have 3 lots of the orange block, let's call it orange, and 3 lots of the 4 green blocks. So we will actually have this. So 3 lots of that and 3 lots of 4. So we have 12 green blocks. So you can see, just as we found out in when using numbers, that the order of operation of the function machine affects the result. We have also found out that using diagrams that the order of operations affects the results also. Okay, what we've learned so far is, number one, we've learned that with two-step function machines, you can use diagrams as inputs, and then you can have different results when you reverse or when you change the order of operations of the function machines. Have a go at question 1. You can pause the video and do question 1 in 2 minutes. You can take longer depending on how your pace of working. Now, assuming you have paused the video and you have really thought about the solution to these questions, here are the answers. Let's discuss them. Here, for question 1A, you're asked which function machine shows the correct output. Tick your answer. We can clearly see that this is the correct output because we have the input as the green block. We have to make 2 lots of that, so which is 2 blocks here, and we're adding 5. This won't be right because remember, we do not know the value of this green block. We can't just add 5. They're not the same, really. We can't just add a number to something we don't know the value of. So we can't just double the green blocks to say 2 lots of the green blocks and then add 5 green blocks. If we were to add 5, it has to be a different colored block to show that they are not of the same value. They're not of the same unit. Let me use that word. They are not of the same kind. Okay. We do not know the value of the green block, but we know that we have to add the number 5 to it. So here we're using red blocks to show that we're adding 2 different kinds. Okay. 2 different kinds of quantities. Okay. Here we're told to explain why both function machines are correct. Okay, explain why both function machines are correct for B. Now, for B, you can see that here we have an input. We've doubled it, so that should be right. And then we're adding 5. So you can see the different colored blocks. So it's like adding 5, of which one of these little blocks is 1 unit. Or we can just add a whole block as 5 units. So both of them are correct. And then C, you're told draw a bar model to represent the function machine. To represent the function machine, we can do it in different ways, just like this one was done in different ways. So here we have an input. The input can be this one here. So let me use my pen. The input can be this. Okay. All right. Let's use a different color. So the input can be this one. And then we're adding 5. Okay. We're adding 5 to that, which is this. And then we're doubling it. Okay. We're doubling it. So same with this. Okay. So it can be this or this. Okay. So let's move on. Okay. What if we have something like this? Now we're using letters. So we've moved away from understanding how function machines work, two-step function machines work when we put in diagrams. Let's check letters using letters. Now you remember from our initial lessons about the rules of algebra, you've put in C, you've multiplied it by 4, you'll get 4C, because you remember C multiplied by 4 means you're having to turn one block of C into 4 lots of C. And then you add 2. It's like adding 2 units of 1 each, or you can just add a whole unit as 2. Yeah. So this could be a whole unit of 2. So it's my pen. So this could be like this, C, 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 and then a block of 2 unit like that. So we can also write it like that. So when we finish, our result should be 4C plus 2. Okay. So with letters, we'll get these results in this manner. What about this one? If we add 2, it's like saying A plus 2. So we have a think. I want you to think, what happens if how do we represent this as a bar model? What happens? Okay, I'm sure you would think, because we've done a lot of work about representing these as a bar model. We can have a bar of A. We don't know what the value is. We can have a different bar of 2. Remember, we always add the bars, so we can represent it like this. But now we want to make it 5. We want to make 5 lots of that. Okay, so we can actually now have this. Okay, so it's like saying A plus 2 as a bar, if we were adding the 2 bars, and then we're making 5 lots of it. So the bracket is used, okay, or parenthesis, the way some people would call it, is used to show that we have the bars A plus 2 being added, and we're having to create 5 lots of that. Now, but this looks all mixed up. What if we put all the A's together and all the 2's together? Then we get this. Okay? We get this. So we can actually remember in algebra, we don't actually write the multiplication sign when we write things out. So a proper way of writing this will be 5 and then a plus 2 in bracket. So look at the way we've rearranged it. We've written the number first before the bracket, which contains the letter. And then our result, when we combine everything, will be 5 lots of a, which is 5a plus 10. Now, there is something I want to show you. We're not using it now, but I really want you to think about it. Just have it in your mind. Have you seen this? Just check this out. What's 5 times a? It's 5a. You see that? Have you noticed that this is going on? So what is outside the parenthesis or the bracket seems to be multiplying what is inside. So this looks like this. That's interesting, isn't it? I just want you to have that in your mind, but don't think too much about it now, but we're going to use it at some point in the future. All right, let's move on. So, what we've learned so far is just as we were able to use blocks as inputs to two-step function machines, we can use letters as inputs to the two-step function machines, but we just need to stick to the rules of algebra which we already know. Okay, so I would like you to have a go at questions 2 to 6. Pause the video for about 4 minutes and have a go really thinking about what you've learned and how you would apply it to these questions. Have a go at questions 2 and 3. Assuming you have paused the video and you've thought about these through, you've answered the questions, here are the answers. Let's discuss them. For question 2, we ask, explain the mistakes that have been made in the function machines. Okay. Here you can see that p times 4 is 4 lots of p. So we write that as 4p. When we add 6, it's not going to be 10p. Now remember what we've learned about the bar model. We don't know the value of p. We really don't know the value of p. So actually, if we were to write this using the bar model, this would look like this. So we have a bar that is 4p, and we have another bar, let's use this color, that is 10p. I think blue would be better. Let's use blue. Yeah. We have a bar that is 6. Yeah. We have a bar that is 6. So when we write this, the correct answer should be 4p plus 6. So that's the mistake that was done there. Here we have g plus 6. Yeah, that's fine. G plus 6. But now we're having 4 lots of g plus 6. Right? So it's not going to be 4g plus 6. So if we were to write this out, this is like saying we have a block that is g, and then we have another block that is 6, and then we're going to be having 4 lots of that. That's what it means. Yeah, 4 lots of that. So if we have 4 lots of this, so this is going to be, so g, so we have g, we have 6, okay, so on and so forth. Now you notice something. So if we have another 2 more of this, we have g, 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 and g. That will be 4g. That's fine. This one is fine. But have you noticed that there's something wrong with this one? Okay, that's why I put a question mark there, because we'll have 6 which is 12, and another 2 lots of 6 which will be 24. Now, using the same idea, you will see that this one is right. M plus 6 is fine, but when we do 4 lots of that, it's going to be 4m. Okay, so the number is right, but the term which contains m is wrong. Okay, I hope you recall that and you're really taking note of using these correct algebra principles and concepts. All right, so let's look at question 3. Question 3, you're asked to complete these two-step function machines. Okay, to complete the two-step function machines, m times 4 plus 1 means 4m plus 1. Okay, and then that means m plus 1 times 4, so that will be 4m plus 4, and then that one, that's the answer. So 6h, okay, minus 2. All right, okay, so let's move on. I want you to pause the video for about 3 minutes and have a go at questions 4 and 5. Now, assuming you've paused the video, you've really thought about the solution to these questions, let's discuss the answers. This is the answer to question 4. We're asked, Whitney and Tommy are finding the output for this two-step function machine. So h, add 2, and times 3. Now, she says the output is 3b plus 6. And the output here is 3 lots of b plus 2. It says, show how both of these outputs are correct. Well, we can show that using our block model, can't we? Okay, so if we have b plus 2, it's like saying we have b plus b plus b, and then plus 2, which is a different block. Because we're making 3 lots of that, we can then make 3 lots of the b and 3 lots of the 2. Because remember, b plus 2, we can write it as separate bars like this. Okay, we have one bar, which is b, and we have another bar, which is 2. Okay, so remember, for the bar model, we're always adding. And then if we actually add the bars, so we can have one lot of bar, which is like this. Yeah, so b plus 2. And then we're making 3 lots of that, which is this one here. So both of them are correct. Next, we're asked, complete these two-step function machines. Okay, so again, we're using the principles of algebra. So here you multiply d by 2.5, and then you add 4. Here you subtract. Here you subtract, you do e minus 3.4 times 2. Let's see. Yeah. So then that means, since you're multiplying, it means you have to double. This can be written as 2. Remember, this the example I gave you before. So this can be written as a single block of e minus 3.4, which you had doubling. Okay, so you can have 2 lots of those bars. So the e, 2 of the e's will be 2e minus 6.8. So you're beginning to see the principle here. Okay, here you have f divided by 2 plus 1. So take note, you do f divided by 2 first, which is this one here, before you add 1. So it's really important you take note of these principles of algebra. And here is question 6. You can pause the video and answer this in about a minute. Assuming you've paused the video and you've really worked through this, taking care to think about all the things you've learned, here are the answers. So here, 2g, you multiply by 3 before you add 7. Here, 8h, add 3 divided by 4. Now, you need to be careful to think about this. You have 8h, which is the bar. We don't know the value of h, but we can divide by 4. So it's like having 8 lots of h, 8 little bars of h, and then you divide by 4. Then you have 3 bars, divide by 4. Each person will have a quarter, right? So you actually have 3 quarters if you are dividing 3 bars. So here is what I mean. So if we have this one, so we know this is 8h. We need to divide this by 4. That's 2h. That's good. That's okay. But if we have 3 bars and we have to divide by 4, we have to split each of these into 4 bits. Yeah? Now, if we take each part, that's 3 quarters. Yeah? 3 of each. You're taking a quarter from each. So you have 3 lots of the quarter. That's what it means. Okay. Okay, and this one, you have 7p divided by 3. So it's 7p over 3 before you subtract 5. Okay, what if we have this? So we have two-step function machine. We have the output, but we don't know the input. Well, remember what we learned when we did function machines with numbers. You use the inverse operation to find out what the input was. So here, we need to divide by 2 first. So remember, we divide the 4x by 2. That will be 2x. We divide the 14 by 2. So here, in between, that will be fed back into this function machine, which is to add 3, will be 2x plus 7. Okay, that will be 2x plus 7. Now we need to subtract 3 because the inverse of adding 3 is to subtract 3. That now gives us this. Yeah, so when we divide by 2, this is what we get. So now when we subtract 3, remember, we can only subtract 3 from the 7 block. We can't subtract 3 from the 2x block. We don't know what x is, do we? All right? They're not of the same kind. I want you to think about that. So here we have this. Because when you subtract 3 from the 7 block, you now have 4. So now you have 2x plus 4 as your input. Another way to actually check that you have done it correctly is to work using the function machine from left to right, the way we've been doing when we work with numbers and with letters. So if we put 2x plus 4 add 3, we can only add the 3 to the 4. That will be 2x plus 7. And then when you double it, so now you're doubling everything, because remember that's the input to the function machine, which doubles whatever you put in. You now have 4x plus 14. Okay, so it's time for you to have a go at the rest of the questions. And then before you start, let's talk about what you've learned so far. So what you've learned so far is if you have a two-step function machine, you can actually work out the input that you do not know by doing the inverse operation like we did when we worked with two-step function machines using numbers. And then you have to follow the principles of algebra. You have to follow the principle that for a for the blocks that you use to represent your expressions and terms, 2x add 7 are two separate units. So if, for example, you want to subtract 2 from 2x plus 7, you're not going to be subtracting 2 from 2x. You can only subtract 2 from the block of 7. Okay, have a go. Pause the video and answer questions 7 and 8. You can use 4 minutes to really think about this, to go through these questions. Now, assuming you have paused the video and you've thought about these questions, here are the answers. I'll discuss them. So for question 7, here you ask, complete these two-step function machines. Here we multiply m by 4, so that's 4 lots of m. We write 4m, and then we add 2. That should be the output. Okay. Now, how did we get that? Is by doing the inverse operation. So if we do 4m, because we're adding 2 going from left to right, we need to subtract 2 going from right to left. So here we have subtract 2. Let's use red. Here we subtract 2. So 4m subtract 2, we can only take the 2 from the 2 block, not the m. So we're left with 4m. 4m, now going through this block, the inverse of multiplying by 4 is to divide by 4. If we divide 4m by 4, we have m. Okay. Here, 30r minus 8, the inverse of subtracting 8 going this way is to add 8 going this way. When we add 8, remember, negative 8 add 8 will cancel the negative 8 out. So we now have 30 here, 30r. 30r divided by 5, because the inverse of multiplying by 5 is to divide by 5, will give you 6r. Here is the same thing. We use the inverse operation to get our results. And here are the answers for question 8. For question 8, you ask, here is a two-step function machine. And then Dexter said, I could write this as a one-step function machine. Of course he can, because to multiply by 5 and to multiply by 2 is the same thing as multiplying by 10. So this block here could simply be written as multiplying by 10. And then for B, you're being asked which of these can be written as a one-step function machine. We can write this as a one-step function machine because adding 7 and subtracting 2 is the same thing as adding 5. And then multiplying by 8 and then dividing by 2 is the same thing as multiplying by 4. Okay, this brings us to the end of our lesson. So, what have we learned so far? We have learned so far that we can input, so starting with diagrams, with two-step function machines, we moved on, we made progress to use letters, which is building your foundation of understanding the principles of algebra. And then we also moved on to using inverse operations to find the input when we had the output as expressions or as terms, algebraic terms. Okay, until next time, bye bye and take care.